Service exploits. Services are simply programs that run in the background, accepting input or performing regular tasks. If vulnerable services are running as root, exploiting them can lead to command execution as root. Service exploits can be found using Searchsploit, Google, and GitHub, just like with kernel exploits. The following command will show all processes that are running as root. With any results, try to identify the version number of the program being executed. Running the program with the -- version or -v command line option often shows the version number. On Debian-like distributions, dpkg can show installed programs and their version, using the command shown on the screen. On systems that use RPM, the following achieves the same. Let's run the Linux Smart Enumeration script with the level set to 1 and without it prompting us for a password. We can see near the end of the results that our user can connect to MySQL as root without a password. If we scroll up slightly more, we can also see that the MySQLD process is running as root. We can verify this manually by running the ps command with the aux argument and pipe it through to grep so that we only see lines that start with root. This will show us processes which are running as root, which includes the MySQLD process. Let's enumerate the version of MySQLD by running it with the -- version command line option. As we can see, the version is 5.1.73-1. MySQL has the ability to install user-defined functions which run via shared objects. The exploit displayed can be used to install a new function which will allow us to execute system commands from within a MySQL command prompt. Since MySQL is running as root, the commands will be executed as root, and we will be able to escalate privileges. I've downloaded the exploit code. There are quite a few steps, so I'm going to open the exploit code in the right terminal window and type my commands in the left terminal window. There is a small modification needed to the first command. Since we are using a 64-bit version of Debian, we need to add the -fpic option. That command compiled the exploit. The next command creates a shared object from the compiled exploit, which is necessary for the user-defined function to work. Now we need to connect to MySQL as the root user. We will execute several SQL statements. The only modifications we need are to change the path of the shared object we created, and also the location of the dump file, as this exploit was written for an older version of MySQL. All those statements did was to load the contents of the shared object and dump those contents into a new file in the /user/lib/mysql/plugin directory. Since MySQL is running as root, we have permissions to do this. Now we just need to create a MySQL function which uses the shared object, and finally we can use the function to execute commands. I'm going to create an SUID version of the bash shell. We can now exit out of the MySQL prompt and execute the root bash shell, which gives us a full root shell. Port forwarding. In some instances, a root process may be bound to an internal port through which it communicates. If for some reason an exploit cannot run locally on the target machine, the port can be forwarded using SSH to your local machine, using the command displayed. The exploit code can now be run on your local machine at whichever port you chose. Let's imagine that for some reason we were not able to run the MySQL client from the Debian VM. Or perhaps we just wanted to run some commands against the MySQL server from our Kali machine. We can use port forwarding to help. First, let's determine which port MySQL is listening on using netstat. MySQL's default port is 3306, so this seems likely. Note that it is bound to the localhost address, meaning we cannot access it externally. Let's fix that by using SSH port forwarding. We will run SSH from the Debian VM and specify the -R option. I want to use port 4444 on my Kali machine, and we will forward it to the local Debian port 3306. Finally, we tell SSH that we actually want to connect to our Kali machine. Leaving the connection open, I'm going to switch over to my regular Kali terminal. From here, I can run the MySQL command and instruct it to connect to port 4444 of my local Kali machine using the root user. My traffic is forwarded over the SSH connection, and I connect to the Debian MySQL server remotely. We can confirm this by viewing the hostname.